Welcome everybody to webinar number 26 of our TMS Tuesday series. Today's subject is Airside Computerized Maintenance Management Systems, or CMMS as they're known. And so what we want to do is to basically provide a bit of background to this and help airports understand what they are, why they need one, and how to actually use it. In today's webinar team, we have Tony Smith. Thank you very much, Tony, for joining us. World-renowned PAPI inventor and expert and specialist in all matters relation to airfield lighting. We were just talking about research establishments, or the lack of them nowadays. Tony had the very good fortune and was a pioneer of a lot of the systems we know today through the research establishment in Bedford, where he was spent many happy years, didn't you, Tony?
Many happy years, too long. If I told you how many, you realise how ancient I am.
No, that's good. So we also have Helena Shapton will be joining us today for the first time. Obviously myself and Keith, I hope will be able to join us. He is currently training overseas and is rushing back to join the webinar, and I hope he will join us a bit later on. So today, as I said, it's Airside CMMS, Computerized Maintenance Management Systems we're talking about. And this comes back to the fundamental that we've been talking about throughout, the theme that runs through all of our webinars. You cannot manage what you do not measure. Absolutely essential to the field in which we work. And we're talking about why you need a CMMS, the regulatory requirements pertaining to a CMMS, how CMMS works, what it does, and then we're going to finish off with some real-time examples, which will show you not only how to use it, but what the benefits are. Regulatory compliance is the big win here, but as inevitably, investment in any technology, you have to justify financial benefits, and there are indeed financial benefits in terms of efficiencies and savings for the airport. So first of all, as I said, safety and compliance, the number one reason for a CMMS. If you're running an airport operation, you're providing equipment, or if you're working at an airport, the safety of the airplanes and, of course, the people working at the airport is of paramount importance. For the airplanes, it is essential the visual aids are operating in a safe and compliant way, giving the pilots the visual cues they need to land and take off safely. And for you working at the airport, you need to be working in a safe environment. As you will have heard in our last webinar, the airfield electrical system is extraordinarily dangerous, especially if you're not well trained and well versed in the dangers. And so a functioning CMMS will help you manage and monitor safe operation for yourselves as well as the airplanes. So today we'll be talking about the safety, not just safety personnel, but the maintenance objectives for the aerodrome, the maintenance practices, and record keeping. But first of all, the requirements. All the airfield regulations require that, and starting with ICAO at the top, of course, that airports have an aerodrome manual that documents the processes and procedures that must be followed to operate safely and to demonstrate compliance. An airport must be able to demonstrate their processes documented in their aerodrome manual have been followed, and they must be able to demonstrate the results of following those processes are compliance. So did you do what you said you were going to do? Can you prove it? And when you prove it, do those records demonstrate that you were successful in meeting your objectives, and the airfield visual aids in particular are compliant. And as you discover faults on the runway, have they been recorded, and can you show that they were fixed in a timely fashion? So, do your airports have the records that demonstrate safe operation? The compliance is for a long time, there's been an attitude prevailing in our industry that it's somehow the airport inspector's responsibility to come around and check up on you. And if you get a report that doesn't identify any failings, then you must be okay. It's somehow the responsibility, the monkey has shifted to the airport inspector. However, this is not the case. It is the airport's responsibility. And we're seeing this far more now in the means of, in the way in which airport regulators are operating. The airport inspectors will come and inspect your airfield, but in the event of an accident, that's when the airport inspectors will inspect you to demonstrate, that you have followed your processes and procedures, and your records demonstrate that you have been compliant. And it's you need to have these records ready and available at all times. So how well prepared is your airport? There's an example from an incident a few years back, and this is an actual letter which we've redacted the names, where a regulator, sent a letter of correction following an incident. This concerned an issue relating to torque management, where a light came out of the runway and damaged an aircraft. And it was discovered that the maintenance practices hadn't been followed, and that wasn't something that was routinely inspected by the FAA in this case before then, or even since then. It is the airport's responsibility to do it, and if it's not done, then the records will if you can't prove you've actually followed the procedures, then I'm afraid you will suffer the consequences, because it's not an FAA duty or airport regulator duty to tell you how to do your job. And just a small point, there's no limitation of the time to keep those records in the standards either. So there may be individual national authorities have a timekeeping, but officially there's no time limit for keeping records. So you need to store the records, but then there are advantages to doing this. The benefit of the CMMS is that by recording the activities, you will actually have a large amount of data that you can mine to the benefit of the airport. And we're going to give some true life examples of how that works over the next few slides. But first of all, what is a CMMS? Some of you may recognize this chart from the differential maintenance philosophy that we at TMS have pioneered in the industry. It's a maintenance circle, really, starting off with measurement, collecting accurate, timely and reliable performance data, following by maintenance, where work is scheduled on the basis of the measurements, following by monitoring the effectiveness of the maintenance, that it took place in the required time scale and the results were as desired, and that any faults were fixed in a timely fashion. And then all of this information is stored in the CMMS and then used to help manage the airfield or the enterprise that's employing this management system, to help improve the maintenance loop by becoming more efficient, learning the lessons from the measurements and the maintenance and the monitoring process that has been engaged in. And in particular, if you look at ICAO Aerodrome Manual, the latest manual issued in 2021, Part 4, Aerodrome Design, ADM Part 4, Chapter 18, actually refers to this maintenance, the differential maintenance process. So, coming on to the CMMS in particular, a CMMS is used to plan and control the maintenance of an airport. It is integral to the airside operations. You can have a a paper-based CMMS, of course, and a lot still do. But those processes used, commonly termed as PMs, are the process used to actually plan, control, and manage the maintenance of the airfield operations. It centralizes maintenance information and facilitates a process of maintenance operations. It's about managing the whole process. All the information is stored centrally in a computerized CMMS and is integral to the management of the maintenance operations. It will allow, when used effectively, the optimization of assets and the availability of compliant visual aids at all times, but in particularly in low visibility conditions where they're so critical. And we're talking here about the signs, the lights, the PAPIs, the standard apron lighting, as well as other airside assets, as we see a CMMS can be used to help support management of the civils, so the pavements, and also other areas we've seen to use to support the SMS operations. And we're talking further about integration with the other third-party asset management systems, potentially areas like friction testing and wildlife management. And of course, then the computerized CMMS will also allow for scheduling of the preventive maintenance actions and any repairs, the record keeping for those to evidence the fact those works took place, the results of those works and any remedial actions, and to track any assigned tasks to ensure they're done in a timely and a cost-efficient manner, monitoring the inventory of critical assets, for example, airfield lights, and tracing the faults by type of fault, so that to help you actually manage your airfield more effectively. You may find if you have the records, you can identify things like epidemic failures in lamps, for example, or other key components. But then, of course, a key feature of any CMMS is it is also very useful to help demonstrate the airport is operating safely, and by regulators to verify regulatory compliance. Of course, this can be done manually, but it requires an enormous amount of time to do that. And trawl it, and then the records are very difficult to use if they're maintained on a paper-based method. The alternatives are then for computerized systems to use an enterprise asset management system. So we're talking here, for example, Maximo, SAP, or Oracle, or to use a specialized airside CMMS. These are different. These are quite different. The enterprise asset management tools are much more enterprise-wide, used more for financial control, management, and reporting. Whereas a CMMS, they are more industry specific, related to the tasks and activities commonly used in that environment, and in your cases, airside operations. Too often we see airports trying to run their CMMS through as if it were as utilizing an airside enterprise asset management system. You just need to look at in researching for today's paper, I looked at the IBM website, and if you look up CMMS, they specifically explain the differences between the two, and they do not claim that Maximo which is an IBM system, is a CMMS. They advocate a CMMS working in parallel with a Maximo or enterprise asset management system. So we're coming back to the circle we described earlier. First of all, we measure, then we maintain, then we monitor, and we manage. Differential maintenance, as it's known to many of you. So the measurement cycle. Initially, when people say, well, how do we get started with our CMMS? I always say we should try and keep it simple. Schedule your PMs, your preventative maintenance actions, in the CMMS to start off with, so that you can get used to using it based on your current working practices. Every airside operation has a massive list of these operations. If you don't, and I know if you don't for whatever reason, I can point you at several established documents that will list the type of activity to follow and the periodicity. So how frequently you should actually do them. How often do you do an inspection? How often do you do photometric testing? How often do you clean your lights? How often do you how often do you measure your circuits, etc., etc. There are an awful lot of tasks that you should be routinely performing, and there are a number of documents out there with recommended periodicity for performing these tasks. So the first thing is to actually put these things into your CMMS, so that you can actually in a disciplined fashion structure the carrying out of these tasks. So this is the measurement phase, where you collect accurate, reliable, and timely performance data. When, where, and what is required. You do it on a daily, weekly, it could be bi-weekly, monthly, 6 monthly. Every task has its period, and it will vary airport to airport based on what you learn from recording the results. So, for example, we performed a study on the cleaning cycles required to maintain compliant lighting at a major UK airport, and we discovered in winter months a cleaning cycle of 8 days is optimal. So it is what it is, but it should be based on the conditions. Oh, and by the way, when de-icing occurs, then you need to clean immediately, because the de-icing destroys the photometrics. Then there are other tasks, such as photometric measurements, where you would test your infield lighting, you would test your repaired fixtures in the workshop, you would measure your PAPIs, you would measure your guidance signs and apron floodlighting. There are also the mechanical types of measurements you take, for example, torque checking each time you install a new fixture, or periodically just to check that the installed lights haven't come loose. And that would typically start off based on the manufacturer's requirements, but as you'll see from the heat maps we'll show you later, that can be varied based on experience. And then finally, the electrical measurements, where you would be looking at insulation resistance and measuring it and taking CCR records, and looking at open and short circuits, keeping all of these, recording all of these things that you can actually use them to help with your maintenance activities. Maintenance activities should be based on the results of your measurements, of course. You only do work when the work when it's required. You routinely changing all the light bulbs, spot block change as it used to be known, is not efficient, and it's expensive. You don't need to do it if you have a differential or preventative maintenance system employing photometric testing in place. You only do what is required. You do the work that's needed based on the needs of the location, and you only do it where it's required, of course. If fittings are serviceable, they're left alone. Examples would include of maintenance, cleaning, relamping, realignment and replacement in the case of visual aids, and the mechanical failures you would either repair or replace. And for electrical issues, you have to go through an investigative process and then either repair or replace the electrical infrastructure concerned. Looking then, having done the measurements and the maintenance work, you then next turn to the monitoring process. This is where we would use, for example, a MALMS KPI dashboard, which would show your key performance indicators in a single glance, which will allow you to have a view as to what is actually required on the airport. You would then focus on task completion. Have the actual PMs, the inspections taken place? Did the cleaning happen in the period that was specified? Is the airfield lighting compliant? And if not, you should be able to drill down through the system to determine which service is not compliant, and then within the service, which light is not compliant. And then by looking at the isocandela diagrams for that light, why is it not compliant? Because you can often tell from just looking at the records. And certainly looking at the history will give you a very good idea. And we'll look at some examples of that in a minute. Torque status is very important, particularly for those for inset fixtures, that the torque of those lights is tested at regular intervals. And as you will discover, if you do this and you have a system that can give you show you how loose the lights were when they were torqued, won't come as a huge surprise to discover that the high impact areas such as touchdown zones and the rapid exit turn off areas are the areas where the lights tend to be the bolts tend to loosen fastest, and more maintenance is required. Looking at other areas, insulation resistance, fault status and PM status, all this information is available for you to monitor that the actual work has taken place, that the insulation resistance hasn't fallen below the maintenance level, or heaven above, below the red line to say that the circuit should be turned off. It's critical safety feature. Fault status, again, faults will occur. You need to set your parameters for how quickly they should be fixed. And the fault status reports will identify the number of faults, how fast, how many have been fixed, how many new ones have been identified, the mean time between failure, and therefore, if you're keeping on top of your maintenance. You don't want to be in a situation where faults are accumulating beyond the rate at which you're able to fix them, because that can only lead to non-compliance. And then finally, the PMs, just checking that everything has actually been done that was required. So we now look at the management element of it, and this is somewhat the most interesting part of the process, because when you gather all of this data into your CMMS database, a feature of all CMMS systems, you will be able to draw on an enormous amount of information to help you identify the performance of your assets, as your runways, your taxiways, your stands as a whole, and to help you manage your infrastructure, your asset infrastructure, including the pavement itself, to optimize its useful life and to minimize its cost in service, which is the optimal outcome for you all there. Clearly, whether it's the runway, the lights, the stands, or the aprons, they must all be kept in a compliant condition. That's absolutely mandatory. But it is our, as well as doing that, it's our task to actually manage them efficiently and effectively. So to do that, we use tools such as heat maps. And again, these, we'll show you some examples. These are reports which will show you the areas which have repeat failures, would highlight the areas with repeat failures to draw your attention to the problem areas that need to be the focus of your attention. Asset history reports, these are particularly useful to help you look at measurement trends. But then when combined with other data, they will actually help you direct your maintenance activities to eliminate waste and inefficiency. So, for example, if you can see that a light is continually failing to meet its photometric standard, there's no good cleaning it every week, when in fact the problem is the scratched lens of the light, which is not letting the light through. But by actually using asset history reports, you'll be able to identify these factors and address the real problem, which is the lens issue, and fix that, so you have a compliant light. So this is how we would use measurement trends. One other item which we'll show you in relation to measurement trends was the one airport identified, one airport were, I believe they needed to replace their halogen lights with LED lights because of the amount of maintenance was required. Quite naturally, their financial people required them to justify this very large investment in LED lighting, and they were able to do this by actually, because their CMMS system traced the frequency with which faults were being identified with their lights, non-compliances, and the amount of work that was being done on the runway, and which they were able to cost and use the basis for the investment in new LED technology. And then, of course, they were able to trace, very important, when you've actually done something differently, when you've implemented a change or an improvement, you need to monitor the effectiveness and the results of that change to ensure that you get the results that are inspected. Another area is IR/VR reporting. We've talked about this before, but it's critical to low visibility operations that IR/VR reporting is accurate. And remember that if your runway light performance is less than is programmed into your IR/VR system, your runway visual range will be overstated, which of course is dangerous. So you must have the correct runway visual range information being reported, and secondly, to optimize your runway visual range, you would have lighting that performs to the required standards. And certainly in the UK, the Civil Aviation Authority has a program to support IR/VR credits, which rewards airports for maintaining compliant airfield lighting. And then finally, the key performance indicators you will get from your CMMS will allow you to identify any problems or issues. It will highlight them so that airports can actually avoid problems and optimize outcomes. So here's some examples of how we, Mr. Zahid, if we can, we'll come to your question. If we could take questions at the end of this presentation. If you have, if you could please use the box at the bottom of the chart, you'll find that you have an ability to log a question, and we'll go through those, and I'll leave about 20 minutes at the end of today's presentation. So looking at some examples, I'll just run you through quickly. These will all be posted on the TMS Training Solutions website, so you can ask any questions if they're not clear. This is an example of asset serviceability using the MALMS Engineer CMMS. So for this, because this airport does the photometric testing, has the bench tester and the CMMS, and does regular cleaning, which is all recorded, you can see here the photometric performance on the left-hand side, on the left-hand bar. You can see the ISO candela for the particular light concerned. And then you can see the history of that particular light, showing the photometric tests for the forward direction and the reverse direction. So each side of the light is shown. It shows with a pink mark when the light is replaced or repaired, and it shows with an orange block at the bottom when it's actually cleaned. And the last 10 maintenance actions are listed at the bottom of the table showing who performed the task and what the outcome was and what the result of the change was. So in this particular instance, if you can see my marker on this, you can see here this light was changed at this point. Oh, if I can, this light was changed early in 2020 after it was cleaned, and the result did not improve, and immediately the photometric performance went up. So in this particular airport's case, you can also see here, this is when the LED, this is the example I was telling you earlier, where LEDs were introduced. Prior to LEDs, this light was always failing, and even when they cleaned it. But then when the LEDs were introduced, the photometric performance jumped up and has pretty much always been above the 50% fail level since then. It's dropped to just on 50, but it's been a very good performance since that date. So the question that was raised in this particular, and this was a quote from Stephen Ryan at the time at Stansted Airport. He said, "How can you manage an airfield? How can you manage your airfield without this basic data?" And that's what I would ask you all to consider. A CMMS is, in my view, essential to managing a safe, efficient, and a compliant airside lighting operation. So here's an example. This came up purely by chance this weekend. I was looking at Instagram, and I follow Mo Taher, who works at Heathrow Airport, and is a real promoter of, and his little short videos cover a number of areas outside of airfield lighting, of course. But he happened to be on the runway last week, and he took this little bit of film, which I'd like you to see, which is a great example of how a CMMS is used.
So we found the light that needs cleaning. Unclean that runway light. When you click the trigger on here, the soda gets shot out of this nozzle and cleans these lenses. It actually sends the GPS signal via this transmitter. There's a transmitter just over there, the black one. And that tells the GPS that light has been cleaned. And every time you go from one light to another, it records on the GPS that the light has been cleaned, and then you can move on to the next one. And then in our maintenance strategy, we'll be able to actually identify if this light needs changing or if it just needs cleaning.
So that's Mo Taher. I recommend you can find him on Instagram or TikTok. He posts a lot of very short, entertaining, but highly interesting airside type of videos from Heathrow Airport. But so what are we looking at? What's he talking about here? So if we look at some runway lights and they're failing, you then clean those lights, okay? And that's indicated by picked up by GPS, and that becomes a yellow line. And at that point, you can see you do another photometric measurement, and normally the light improves. But just sometimes, here, for example, the light improved, but it's still below 50%, which is a fail. So what do? They replace that light, okay? They replace the light, and immediately that light becomes serviceable. So what we're demonstrating here is just cleaning every light, that every time they fail, they could be beautifully clean. But if there's a problem, and in this case we're talking about lens issues, then you need to replace that light. And we see this at a number of airports all over the world, where particularly where there's snow removal, or there is a lot of sand or grit on the runway that could be blown by the jets on the planes taking off in particular. You will find that jet blast and scratch lenses from ice removal equipment destroys the performance of the airfield lighting. So another example here oh, this is looking at the cleaning again. This is another airport. This was using hand cleaning methods and then using the cleaner. Okay, and what you should bear in mind, of course, this airport is compliant. It's still compliant, but the better the result you can get from the cleaning means the less maintenance, the less interventions you have on the runway. And I'm talking in particular in relation to this airport, they have a single runway, and with a single runway you have, and it's open 24 hours a day. You don't have any closures. Doing maintenance is expensive because it requires runway time when it should be occupied by planes. So cleaning your lights and doing your maintenance to get the highest photometric performance possible is very, very important and beneficial to the airport. So what else do you use for the CMMS for? Well, performing scheduling of the operations. So as we said earlier, when you've identified the PMs that you're going to, and any remedial repair works, you then schedule that work on the system for the airfield engineers or electricians to perform. And you schedule that work on a particular night or in a particular window of time for them to perform. And if that's not performed on time, it will be highlighted in red. So that tells you that task hasn't been performed when it should have been. So you need to address that as a priority. But this is how you schedule and you monitor the performance that the maintenance actions have actually taken place as you planned. Again, within the asset management, within the system, you're recording the number of faults you've got, and you can see here if you've got a number of faults, you can see how many assets are faulty, how many faults are outstanding, how many were reported, how many resolved, and then how many are outstanding. And you can do this on a periodic basis to help you make sure that you're keeping on top of your maintenance activities. Because if maintenance is allowed to get out of control, your lighting system will become non-compliant. In this airport, that's not allowed to happen. And you'll see both runways are compliant. All services, of course, within those runway operations are compliant. And they're able to report that information in a clear, understandable means to their airport operations, SMS, and of course the CA regulators as required, inspectors as required. Here's another, this is an example used where a CMMS is used to justify an investment. So based on poor photometric performance based on poor photometric performance in the past, the amount of maintenance activities was absolutely huge. Nothing could be done to actually maintain that airfield lighting system at a compliant level with a great deal of intervention. You can see that the amount of time the lights were spending it below the maintenance level. So as a consequence of that, the decision was taken to invest in a new LED lighting system. You can see, I'm trying to get my cursor to move about. It's, pardon me, I can't use my cursor. So you can see in the middle of you can see on the bottom chart shows the number of reported faults. And up until August, they suddenly come down. And you can also see in August 2018, the LEDs were deployed on that runway. And so the serviceability on the top photometric chart, you can see the photometric performance improved immeasurably from the point at which the LED lights were deployed, and the number of faults to be fixed reduced enormously, which was the purpose and the cost benefit of actually doing this, performing the upgrade to LEDs, but also, and most critically, that it was much easier to maintain that airfield on a compliant basis, particularly as they were just approaching the fog period for the year. The same practice can be used to monitor the performance of LED signage. I know a lot of you still have incandescent light sources in practice, in use for your signs, and you will recognize, as you can see in these charts here, the very poor illumination on these signs that can and is being addressed through the implementation of LED signage systems. And so you can see the before and after for this one particular sign. But again, the key to that is measurement and monitoring the system using a CMMS. Bear in mind, all of these reporting tools put all of their measurements into the CMMS, which then uses it to produce management reports to help monitor the performance and produce the analytics to support the investment in this case, an upgrade to LED signage. We spoke earlier about IR/VR. Again, investment in cleaning technologies and demonstrating good and LED technology here demonstrated the performance levels improved, and the CAA have supported the business case. And I can tell you now that in this case, Stansted Airport has the, I think it was the first airport in the UK to achieve the 80% IR/VR credit for their IR/VR system, which reduces the time they spend preparing for low vis, the time they are in low vis, and it has benefits for the airport's reputation, has benefits for the environment because airplanes are spending less time circling, waiting to land. And of course, it's improving safety, which is the most important consideration. For you and your airport operations, a CMMS can be very useful to measure warranty management. So you're able to track how long you've had a light, such that if you have any failures, you can compare lights or signs or PAPIs or any other equipment for that matter. You're able to monitor by recording when the service was brought into use. If you have any failures, is it within warranty? If it is within warranty, then you have recourse to the manufacturer, which will save you a lot of money. It'll help you to measure mean time between failure, so that if a lot of the analysis of or perception of problems is based on perception rather than fact, but by using a CMMS and having the dates when things were installed, when they were repaired, the cause of the failure, was it a lamp failure, was it a lens failure, was it a torque failure, you can start to manage the particular down to each individual asset to see if there is a particular issue. Then you can work with your manufacturer, your OEM, to actually resolve the situation in a proactive way. But it's only by having the measurements, it's only by having the facts and the analytical proof to support your arguments that you will be able to make progress. Otherwise, it's always deemed a matter of perception. With having a CMMS, you have fault tracking and you have traceability. Using a CMMS can be very useful in relation to pavements. We discovered when we started using this for visual aids, airports were using their tablets for inspections and said, well, can we record faults? Can we use the camera? And they started to use it. And so from that point, they were able to report the defects by different type of problem they have with their pavement, introducing colored severity codes so they could prioritize different sorts of actions, and certain sorts of faults were deemed for monitoring, and then they were able to actually prioritize these and collect them together and plan overlays based on grouping the types of faults and the areas they were in to have more efficient repairs and maintenance of their pavements, and also recording when the work was done, you know, what was done, and so they can actually have a traceability as to the effectiveness of different types of repairs. When used with a photo bench, as you know, if you don't, it is absolutely essential to, when you repair light fixtures, that you test them before you put them out on the runway. It is too easy to repair a light incorrectly. And when I say incorrectly, it could be incorrect because the components you're introducing aren't good enough. So if you put a bad lamp into a light, it will not pass photometrically. If you put the internal mechanics in the wrong way around, then the light will be aimed in the wrong place. Either way, you will have a light that will be non-compliant when it's put out on the runway, which is a very expensive mistake to make and will lead to non-compliance. So test your lights on your workshop tester before you put them into the runway. This system will also allow you to monitor mean time between failure on individual lights, so you can start to track the efficiencies of individual light types and components, for example. You can also use it for, and very importantly, for management reporting. With all of this information, it is vital that it's not kept in-house. We're just introducing, for example, a NOTAM report that will, if the photometrics, if the runway becomes unserviceable, you can create a NOTAM report to notify, to create a NOTAM such that the airplanes are notified that if there's any, that the airfield is non-compliant for whatever reason. These faults, though, notified, can also highlight situations, all too common, of unavailability of runway to actually perform the repair. The number one issue we have in our airside AGL maintenance is that we don't have access to the runways to actually perform the work. Now, that, first of all, you can't repair things if you can't actually get to them. And the second thing is that you need to have the tools to do the job as efficiently and effectively as possible. And these are both, and reporting information is critical to achieving both of those goals. The third point is it actually enables you to demonstrate what a good job most of you do out there. I see some marvelous examples of compliant airfields, and you should be unashamedly advertising the results of your good works. However, if you're not able to achieve compliance for whatever reason, then equally that you need to address the causes of that non-compliance. And if that cause of non-compliance is you not gaining access to the runway, then that is what needs to be addressed, because you can't have compliance without access. And then finally, a feature of any CMMS should be an airside map to enable you to navigate around the airport, to be able to look at the different layers of assets. So if you're particularly interested in civils faults, then you would just be able to look at those. If you're just responsible for photometrics, you can look at photometric faults. And if you're looking at torque management and torquing lights, you can just look at torque. And so that would be a feature of any CMMS. The fault status should be shown clearly to help you identify and then find those faults using GPS and RFID. And you should be able to run reports, asset reports for each individual asset to see if you identify a fault, what is the fault, and how can you address it? How can you fix it? And then when you do fix it, record how it was fixed, and then it's cleared off the off the list for things to be done. So simple remedial actual scheduling and closing of completed faults is very important, and as I said earlier in the presentation, a requirement of CMMS and regulatory reporting requirements. This is we're running short of time, so I'll just run quickly through these now. This is an example of an individual asset report showing all of the light is this light is unserviceable, but it has been cleaned, it has been torqued. The photometrics are positive on both sides, but a physical inspection clearly has identified it's not illuminated, and that's been outstanding for 10 days. So these are the complete history of any particular light at any particular time. This is an example of a heat map report, so you can see the red dots indicate where there have been more than a certain number of faults identified in the period that you've actually analyzed the system for. So you can see there some centerline torquing issues, which is where you would expect to see them. And then here we've got some civils faults identified on a map. So you've got all these different layers, so you can analyze them according to your own particular responsibilities. So what I'd like to do now is just jump into the question and answer session, because we're running short of time. Before I do, I'll just highlight that next month's webinar is on the 29th of November, and based on your requests, we're looking at LED lighting. We have a lot of questions around the subject of LEDs, but we'll do a short presentation on lessons learned 20 years on. It's 20 years since we first saw LEDs used on runways. So we're going to do a 20 years on lessons learned LED lighting webinar. So without any further ado, if I could go on now to any questions you may have asked. Our panel of Tony, Helena, and possibly Keith. I don't know yet. We'll have to see when I stop sharing. No, Keith is not here. Right. So anyway, right then, we have a question here. The question I have here, first question: is it safe to use high pressure water to clean the lenses of a light whilst it's activated? Tony.
Good question. I don't know the answer to that. I mean, obviously, you're putting cold water onto a hot surface, and you're worrying about contamination, damage to that. I would think probably okay, but I think do a test and find out for sure.
Well, I can say, Tony. So sorry, it's a bit unfair there. I just I see Keith has joined us. Hello, Keith.
Hello.
The thing about there are a number of methods of cleaning lights. High pressure water gets into lights. Oh, high pressure. You've been working, yes. Yeah. So high pressure water gets in, does get into the lights themselves. And is unfortunately a cause of lamp failures, and particularly with LED lights. I would never recommend using high pressure water. This is why we developed in TMS sodium bicarbonate of soda cleaning, an air cleaning system. That's what Heathrow were using in the video you saw earlier. Keith, what's your experience of cleaning runway lights?
Well, I it's coming back to the thing. There's two elements. I mean, there was the ice type cleaning, which that created. I did a lot of trials and many years ago with that, but that created a thermal shock.
Yeah.
on the light fixture, which damaged the in itself damaged the seals, which of course thereafter allowed water to ingress into the light fixture. So you got that thermal shock element where the aluminium alloy of the body of the light fixture actually expanded and then contracted, etc. But of course, one of the issues that was actually identified following an incident many years ago, and there was a full investigation associated with it, was the fact that that depends upon the material that you're using. If it has a high pH value of a cleaning fluid, it actually damages the structure of aluminium alloy, and so weakens the light fixture. It happened on an international airport, and when the airfield inspection team went out to do the standard runway inspection, they said, well, we found part of a light fixture. Where is the other bit? Well, it was found many thousands of kilometers away on another international airport, embedded into the side of a 747.
Mm-hmm.
And what the investigation that ultimately took place eventually identified the high pH value of the cleaning fluid that was being used on that particular airport. So the choice of cleaning and the methods of cleaning and the tools for cleaning is really an important factor. So I welcome the fact that when I found out that you was using a biodegradable material, basically a baking powder, that's what it is, fundamental, the bicarbonate soda that your organization, the TMS organization has developed is ideal, because it also is meeting the modern green issue element as well. But they're the key issues. They're the two experiences I had: high pH cleaning fluid, and secondly, the thermal shock from the ice cleaning.
Yeah, and unfortunately, I've witnessed in many times people trying to manually get rubber off fittings, and they use various sorts of scrapers and wire brushes and things.
Yeah.
And
I did hear, Robert. I did hear most recently, actually, the cleaning, the cleaning method that is the tool that you use, whether it's an automated or whether it's the handheld system. I heard somebody refer to that as a sandblaster. Of course, it is not a sandblaster, eh?
No.
It's bicarb. It's inert material.
Very soft as well.
Yes,
it's incredible. It's used by the people that clean the graffiti from historic buildings, which are often made of very soft stone, and it's used because it is so gentle on this stone that it will not damage these historic buildings. So no, it's quite good. I've got another question here, kind of related. Is it the same case when we have strong rain, when airfield lighting are turned on? So that's a kind of a different question. Heavy rain on airfield lighting.
Well, if you get heavy rain, then there's going to be water laying. Yes, we have the camber on the runways, for example, and it could be with slots in some cases, some runways for anti-skid, etc. But we have the camber from the center line, and the water is designed to run off. But what is also interesting is the design of the fitting itself, because quite often when you look at the heavy rain and then you look at a light fixture, because of its design, an inset light fixture, the design, you see a little puddle of water just in front of the lens.
Yeah.
So actually, the slope of the casing is in the wrong direction. It's allowing water to run onto the lens, and therefore the light is being is trying to shine not just from the light source and through the lens. It's also got to shine through water, and that's going to dissipate the light, and therefore potentially reduce the light output of what is seen by the pilot, or what is measured by an in-field photometric testing tool.
Yeah, I've tested a number of runways in heavy rain, new LED installations as part of a commissioning process, and had to abandon them because, frankly, the LED lighting, there's no heat to, and this is on a properly grooved system, but there's no way for that water to escape from the front of the lens. And indeed the grooving washes water down. I couldn't even wipe it away fast enough, and the consequence is in low visibility conditions the lights are not performing, which is a rather concerning state of affairs. I believe it, you know, so I've seen a couple of methods to address it. I've seen a couple of types of light fixture with a big hole in front of in front of the lens, so it drains the water away using the can and the duct system, which is an interesting approach. The concern there is in cold places, of course, where if that water freezes, what happens then? The other method I've seen is, most recently, I've seen one manufacturer has introduced a fitting that the bullnose fitting that slopes, where the slope is down away from the lens, and I've seen some with a neutral slope, so they're not sloped one way or the other. Again, I have to do more testing.
What you're really saying is, whilst this webinar is about asset management in total, then you're identifying the fact that the records that from the inspections of from the airports that are using the tools that you produce is actually, you may have a lot of information which, of course, many people will never even see, and you getting that information in real time.
Yes, and see, so what you would see, for example, is on your asset history report, you'll see that a perfectly good lighting system, all of a sudden, one photometric test will be absolutely disastrous. All the lights for your beautiful new system will suddenly be below the 50% compliance level. And what is the reason for that? Well, it's just simply rain. But of course, the fact is that that's exactly what the system is there to do, is to provide the visual cues, particularly in low visibility conditions. And what is heavy rain? Low visibility conditions often. So that there's a bit of an issue there, and I think we'll talk about it some more at next week's 20 years of LED seminar. Well, next month's webinar.
Mm-hmm.
So right, I've got another question here. Hi to David Rainey there. Yeah, we look forward to seeing you. I'll give you a call. Love it if you could join us to give us a US perspective on things. Bernardino, what will be the effects in the CMMS if we're using two intensity taxiways? One is low intensity while the other is medium. although our runway is Cat 1 only. Not sure I follow that. Keith, do you get it?
If we are using 2 intensity taxiway lights, one is low intensity and while the other is medium intensity, although our runway is Cat 1. So what is the effect in CMMS? Well, you're actually measuring the photometric output, aren't you? If you're using, I assume you're talking photometric measurement here.
Yeah, I think it
And
is.
in photometric measurement, there is a standards. And what you're measuring is against the standard.
Yeah.
So in if you want to measure what it is low intensity, then there is a standard for low intensity, although the definition of low intensity is different in various parts of the world. So you have to be very careful of what the local standard is or the local definition is for low intensity. Whereas the other medium intensity, it tends to be an FAA standard, generally speaking. But of course, each one of those has an intensity light output of the light fixtures, and there is a design criteria for them. So any measurement is against the design criteria. On the runway, if it's a category 1, there will be high intensity lights with the ability to turn then the brilliancy down, the intensity down in the 5, well, if it's a local 5 steps.
Thank you, Keith. Right. Well, we've believe it or not, time has passed in the blink of an eye. We're 10 minutes past 3 now here in the UK, and 10 minutes past something else if you're anywhere else. Or in Keith's case, what time is it?
10 past 10 in the evening. I'm in Asia Pacific.
Right. So thank you very much for joining us, Keith. Thank you to our panelists and thank you to Damon, Felicity, everyone for putting it together. I'd like to thank you, our participants, for joining us today. Next month's webinar on Tuesday, the 29th of November, just to keep you awake, is at half an hour later. So it'll be in UK time, it'll be 2:30. We will send out emails beforehand, but the subject will be LED lighting 20 years on, the lessons learned. So we will have a wide-ranging discussion about the development to date of LEDs, what we've learned about them, and we'd like if you have any questions, please feel free to send them through to us beforehand, and so we can prepare answers for you. But I think it'll be a very interesting and hopefully illuminating webinar for us all. Thank you very much and see you all next month. Cheerio.